This IPCC report summarizes decades of research from scientists worldwide and focuses on two crucial parts of the climate system: oceans and ice. Climate change has already reshaped both. The ocean has borne the brunt of the impacts. It's absorbing over 90% of the extra heat trapped in the atmosphere since the 1970s, and somewhere between 20 to 30% of the carbon dioxide. That means water has buffered us from the worst effects of climate change. Without it, the atmosphere would have heated up much more than the average 1 degree it already has. But the ocean's buffering comes at a cost. Hotter oceans fuel stronger hurricanes and rainier storms. But warming has also influences less obvious to humans. As the surface of the water warms, it gets lighter, making it harder to mix with the cold, nutrient-rich water below. So the top part of the ocean holds less oxygen and less of the nutrients that support marine life. The carbon dioxide bleeding into the oceans is causing it to become more acidic. This is stressing out any organism that builds its shells out of sensitive calcium, from tiny plankton to oysters and reef-building corals. Already about 30% of the world reefs have been stressed to the breaking point. With 1.5 degrees of warming, the ambitious target, about 70 to 90% of today's reefs will collapse by 2100. At 2 degrees, that number jumps to more than 99%. That's devastating for the reefs themselves, but also for the communities that rely on them. Reefs operate as barriers to soften the blow of storms and waves on coastal communities, but they also are nursery zones for the many fish that feed humans worldwide. If we don't change anything, climate change will decrease fish stocks by nearly 20% by the end of the century. Warming at the ice caps has also a weakening effect on the Atlantic Meridional Overturning Circulation called AMOC, of which the Gulf Stream is part. The AMOC is predicted to weaken in the 21st century, but while a total collapse is possible for the high emission scenarios, it is unlikely for the low emission ones. But any substantial weakening of the AMOC is projected to cause more storms in Europe and less rainfall in South Asia and the Sahel region. But it's not only the oceans that feel the impact. From the high mountains to the polar caps, ice is also being impacted by climate change, and the effects seem to be accelerating. In the high mountains, glaciers are retreating at a 30% higher rate than only a few decades ago. If we do not change our emissions, 80% of these glaciers will have disappeared by the end of the century, creating a vast problem for billions of people relying on them for drinking water, agriculture and energy production. The Arctic and boreal permafrost hold almost twice as much carbon as the atmosphere contains today, and the release of this stored CO2 into the atmosphere would be extremely problematic. The permafrost temperatures have increased to record levels from 2007 to 2016 across polar and high mountain regions globally. At the moment, there is only a medium confidence that these regions have started releasing additional net CO2 and methane into the atmosphere. But this could change if we are not able to curb our emissions. If these vast reserves start to bleed into the atmosphere, it would create a reinforcing feedback loop, initiating warming that would be very hard to stop once it started. In the Arctic, the surface temperature has increased by double the global average between 1979 and 2018. The area of ice, at least 5 years old, has declined by 90%. These are changes that have not been seen in over 1,000 years. The Antarctic ice sheet follows no statistical trends at the moment, and its possible effects are not included in the present-day predictions. But it could become a large contributor by the end of the 21st century, as warm water creeping closer and closer to a delicate part of the West Antarctic ice sheet could initiate a runaway melting situation that could cause large parts of the ice sheet to collapse. As of 2014, part of the Western Antarctic ice sheet has already started to move. Greenland and Antarctica are the primary drivers of rising sea levels around the world. Melt from those ice sheets is responsible for about 1.8 millimeters each year. But the effect is likely to accelerate over the coming years. If we are careful, sea levels will rise by about 40 centimeters by the end of the century. If we aren't, it will be around 80 centimeters. But there is emerging evidence that those numbers could rise much faster if some of the tipping points are crossed. The changes we see are consistent across all systems. From the highest mountains to coastlines and oceans, the choices we make in one part affect many other parts of the world. If we are not able to drop emissions quickly, the next generation's future will look way different from ours. To evade the worst problems, we need to become climate neutral by 2050 and then start to retract CO2 from the atmosphere. Most of the technologies are already in place. Now should be the time to implement them.